So here we're given the problem y equals tan x plus pi over 2 plus 2. First we're going to go ahead and find the period, which is taking the b value, which in this case is 1, because it's that right there, so b equals 1, and we put it under pi. So it'd just be pi over 1, which is pi. Next we're going to find the unit. The unit you can find using the period. So unit is period over 4, so in this case it would be pi over 4. For our vertical shift, that would just be the d value, which is this value at the end here. So our vertical shift is plus 2. Our phase shift we find by setting the things inside the parentheses to 0. So if we set x plus pi over 2 to 0, you'd subtract pi over 2 from each side, and you'd end up with x equals negative pi over 2. So that's going to be our phase shift. Next, we're going to go ahead and do the x and y tables. And I've already filled it in for having the unit be pi over 4. So unit goes from 0 to pi over 4 to pi over 2, and the same way in the negative direction. And for y, it's for tangent, it's always going to be undefined, negative 1, 0, 1, and undefined. So first, we're going to go ahead and do the y shift. So that would be plus 2. Since this value is undefined, we still don't know, so it's going to continue being undefined. For negative 1, it's going to become 1. For 0, it's going to become 2. And for 1, it's going to become 3. For the x shift, or the phase shift, we're subtracting by pi over 2. So negative pi over 2 minus pi over 2 becomes negative pi. Negative pi over 4 will become negative 3 pi over 4. 0 will just be negative pi over 2. Pi over 4 will become negative pi over 4. And pi over 2 will become 0. With all this figured out, we can now determine the asymptotes and plot the points on the graph. Our asymptotes are going to be where it's undefined. So where it's undefined, we have negative pi and 0, which would make our asymptote 0 plus pi times k, where k is an integer. So that means we're going to go ahead and on the graph we're going to make a dotted line to represent where the asymptotes are. So we have 0, and we're going to label these lines here so we can find the other asymptote. I'm going to go with every other line is pi over 4. So here we're going to have negative pi over 4, negative pi over 2, negative 3 pi over 4, and negative pi. And since negative pi is our other asymptote, we're going to put a dotted line here. And now all we have to do is plot the points on the graph. So we have negative 3 pi over 4, 1. So we're going to find that here. We have negative pi over 2, 2. We have negative pi over 4, 3. And that should be it. So the way a tangent graph curves is like this, where it does a swooping motion. So it's going to come down like this. It's going to go up and down forever, but it will never pass the asymptotes, which are 0 and pi, negative pi. And with that, the problem's done.
Okay, so I will be graphing y equals 6 cosecant 1/2 x. So the amplitude is always a, which is in front of whatever trig identity you're going to graph. So for this, it's obviously 6. And then for the period, it's always 2 pi divided by b, which is 1/2. So it's going to end up being 4 pi. In the phase shift, there's no c, so there's no value that you can get for the phase shift, so there's none. The vertical shift, there's no d value, so that is none as well. And then for the unit, it's the period divided by 4, so 4 pi divided by 4 is just going to end up being pi. So next, I would begin putting on the points that correspond with the information I got here onto the x and y axis. So for the x-axis, you would have to put into account the period and the unit. So the unit is pi, so each point must be pi. So pi, 2 pi, 3 pi, 4 pi. And then since it's a cosecant graph, there's asymptotes, so the period is just 4 pi, and there is no shifts, so I'm just going to begin putting in the asymptotes right now. Okay. I'll just continue on. And then so on this way. Put an asymptote down here too, vertical. Okay, and then for the x-axis, you're going to end up putting, I'd put 1, and I'm going to have to, you at least have to get it up to 6, because that is the amplitude. I'm just going to continue on to the top, 9. So, and down. And then I'll just finish this up real quick over here. Okay. So as you can see, I added the vertical asymptotes onto the side and then to the center. And since you know that there's no shifts, you can just go ahead and put in your sine graph, because sine graphs just flow like this. So points are going to be in between each period at the amplitude. So I'm going to come down on each of the asymptotes. So you can just go ahead and fill this out, because you know that there's no shifts and that the amplitude of the graph must reach 6 and -6 on the max and mins of the graph. So, and then once you get these points, you know at the highest points and lowest points is where you add the cosecant part of the graph. So yeah, there you have it.